Bismillahirrahmanirrahim. Dear students, Assalamu alaikum and welcome to office.com.pk. This is your own platform where you come and learn, and we try to provide you with the best shreds of knowledge in the best possible way. I request all of you to please help us grow and improve. If you have not subscribed yet, then please subscribe and hit the bell icon so that you can easily reach any new video. Also, do share your views in the comment section. Your positive views will make us more passionate, and the mistakes and any discrepancies that are indicated by you will help us improve our content. Share it to your fellow students as more and more people can benefit from the knowledge. Thank you so much. Now let us move towards our topic of today. Dear students, previously we have discussed about the preparation of alkanes. We were discussing alkanes. We discussed about the nomenclature, and then we discussed about the preparation of alkanes. Now today we are going to talk about the physical properties and the reactivity of alkanes. First of all, let us discuss the physical properties of alkanes. Now alkanes, you know that there is carbon-carbon single bond. Always remember this. In alkanes, there is carbon-carbon single bond, and alkanes are saturated hydrocarbons. It means that the 4 bonds of carbon are fully satisfied in these compounds. Alkanes that contain carbon number up to 4, when you talk about them, they are colorless, they are odorless, means they have no odor or smell of any kind. While if you start after that from C5 to C17, these are gases, these are colorless, odorless liquids. When you move to the higher members of the family, like C18 and onwards, they become waxy solids. They are also colorless, odorless, waxy solids. Just like you see the petroleum jelly, it's waxy. So or you can observe candle when it melts, so they become like that, the waxy solids. The second property is about, so this was about the physical property of color and odor. If we talk about the second property, they are non-polar. I will tell you later why they are non-polar. Either they are non-polar or weakly polar. They are insoluble. Because of this property, they are insoluble in water or any polar solvent, because water is also polar and they are non-polar, so they will not be soluble in water or any kind of polar solvents, but they will be soluble in polar solvents. You know very well the names of polar solvents. That include benzene, ether, etc., carbon tetrachloride, all that. Now the third property is the physical constants like boiling point, the melting point, the density, etc. They increase, they are directly proportional to number of carbon atoms. Means in the lower members of the class, the values will be lower because they are gases. So gases, they have low melting point, boiling point and low density. While if you move towards higher, they become then liquids. They will have comparatively higher boiling point, melting point and density. When you move to the waxy solids, ultimately you have to provide higher temperature in order to melt them. so their boiling points and melting points will be higher, and ultimately they are denser because they are solids, so that is why their density will also be higher. So these physical constants will be directly proportional to the number of carbon atoms. As the number of carbon atoms increase, so these the values for these constants will also increase. The solubility, if we talk about solubility, which is also a physical constant, it decreases with increase in molecular mass. It is inversely proportional to number of carbon atoms, because the more heavier the group is, the more heavier the compound is, the more difficult it is to solubilize. The boiling point, they have told about boiling point, that whenever you add a CH2 in the chain, the boiling point will be 20 to, there will be an increase of 20 to 30 degrees for every CH2 group. Means, for example, there is a chain CH3, CH2, CH3, and let's suppose the boiling point is 60. So when you add another CH2 chain, it will become 90. There will be increase of 20 to 30 degrees. The boiling points of alkanes having branch structure, the branch structures will have lower boiling points. Now the fourth property is the melting points. The melting points also increase with increase in molecular mass, but there is no regular increase in melting point. Now let us talk about the reactivity of alkanes. This is very important. The alkanes, they are also known as paraffins. Paraffin wax, you must have heard about. So this para is derived from two Latin words, para and affins. Parum. So parum means little and affin is for affinity. So it means that under ordinary conditions or at room temperature, the alkanes, they are very less reactive or almost inert. They do not react with any acid, with any alkali, with any oxidizing or any reducing agents. They have very little affinity or little reactivity towards these compounds, acids, bases, alkalis, oxidizing and reducing agents. However, when you give the suitable conditions, they undergo two type of reactions. The one is substitution reaction, and the other one is thermal and catalytic reactions. We will see the details of these reactions later. Now this is a general discussion about the properties. The reactions take place at high temperature. Now alkanes, you know that there is carbon-carbon single bond. All bonds are highly saturated, they are fully satisfied, they do not need to react. Okay, so that is why the reaction, if you want to complete the reaction, if you want alkanes to take part in any kind of reaction, you need to provide high temperature, sometimes high pressure, sometimes you need a catalyst. Okay, you need light energy. So light energy, so that formation of radicals can occur. Radicals are reactive species, so they will help in the reactions. Now the unreactivity, why alkanes are unreactive under normal conditions, you can explain the fact on the basis of the non-polarity. Unreactivity is due to non-polar nature. Why? Because non-polar nature is due to the electronegativity values of carbon and hydrogen. The electronegativity value of carbon is 2.5 and that of hydrogen is 2.1. So there is no considerable difference. Because there is no considerable difference between the electronegativities, so that is why there is no polarity. In view of this whole scenario, the alkanes are almost non-polar. So ionic reagents such as acids, alkalis, oxidizing agents, they find no reaction site. The bonds are not available for these ionic species, so they could not be attached. Now the single bond which is present is the sigma bond, and the sigma bond is inert. The unreactivated alkanes is due to the inertness of this sigma bond. Okay, it holds the atoms very tightly between the nuclei, which makes them a stable bond, and a lot of energy is required to break it. So this energy is usually not provided, and because of that alkanes are very less reactive. So this is all about the general properties of alkanes. If you have any question, you can ask. Till then, take care of yourself, keep studying, keep watching office.com.pk, and also do not forget to subscribe. Your questions are read by me. I read the comments, so if you'll ask any question, I'll answer it in the upcoming videos. So in the coming video we will discuss about the reactions, the combustion, the oxidation, the nitration, and the very famous halogenation reactions of alkanes in detail with chemical equations. That is all about today. So till tomorrow, and take care of yourself. Allah Hafiz.